In this question, you're given a cubic equation x cube minus px square plus qx minus r is equal to 0. You're given that the roots of this equation are in HP, harmonic progression. And you're asked to show that the mean root, that is the root in between, is 3r by cube. And using the results that you get from the above, you're asked to solve 6x cube minus 11x square minus 3x plus 2 is equal to 0. So x cube minus px square plus qx minus r is equal to 0. Let the roots of this equation be alpha, beta and gamma. Now, it is given that the roots are in harmonic progression. That means 2 by beta is equal to 1 by alpha plus 1 by gamma. So this is the condition which is given. Now, what are the conditions that we know for this equation? Alpha plus beta plus gamma is equal to minus of second coefficient by first coefficient, which is equal to p. Alpha beta plus beta gamma plus gamma alpha is equal to q. Alpha beta gamma is equal to r. So these are the three conditions which we already know. This is the condition which is given. So let us try to simplify this condition and see with which condition is this closely related to. So 2 by beta is equal to gamma plus alpha by alpha gamma. This implies 2 alpha gamma is equal to alpha beta plus gamma beta. So you can very clearly see that this condition is more related to this condition. So given that alpha beta plus gamma beta, alpha beta plus beta gamma, alpha beta plus beta gamma is equal to 2 alpha gamma. This implies the sum of this is 2 alpha gamma plus alpha gamma. So 3 alpha gamma is equal to q. This implies alpha into gamma is equal to q by 3. Now, I have this relation, I have this relation. Let us see these two relations and get some simplifications out of this. Alpha into gamma is q by 3. This implies beta times q by 3 is equal to r. This implies beta is equal to 3r by q. Beta is equal to 3 into r by q, where beta is the mean root, that is the root in between, and this is found out to be 3r by q. So this is proved. Now, this 3r by q is a solution to this equation. 3r by q is a root to this equation, hence this has to satisfy this equation. So let us find a condition. So this implies x cube 27r cube by q cube minus p times x square is 9r square by q square plus q times x is 3r by q minus r is equal to 0. So this is the condition which relates p, q and r. So let us simplify this. So 27r cube minus 9 pqr square plus 3r q cube, 3r q cube minus r q cube is equal to 0. R q cube is equal to 0. So 3r q cube minus r q cube is 2r q cube. This implies 27r cube minus 9 pqr square plus 2r q cube is equal to 0. 1r will get cancelled. So the effective condition is 27r square, 27r square minus 9 pqr plus 2q cube is equal to 0. So this condition 27r square minus 9pqr is good, plus 2q cube is equal to 0. Yes. So this is the condition which needs to be valid if the roots are in HP. If you compare this equation with this equation, so what is the value of P? The value of P is 11 by 6, because in the given equation, there is the leading coefficient is 1. So if you want to compare these two equations, you need to divide this equation by 6. So P is equal to 11 by 6 by comparison. Q is equal to minus 3 by 6 and R is equal to minus 2 by 6. So corresponding to this PQR, let us see if this condition is valid. So 27 times R square. R is minus 1 by 3, whole square is 1 by 9. Minus 9 times P times Q times R plus 2 times Q cube. So as you can see, you get 3 minus 11 by 4 minus 1 by 4 is equal to 0. So for this equation, this condition is getting valid. That means the roots of this equation are in harmonic progression and the mean root, which is beta, is equal to 3r by q. So one of the root of this equation is 3 times r is minus 1 by 3 by q is minus 1 by 2. So minus and minus gets cancelled, 3 and 3 gets cancelled, is equal to 2. That means 2 is one of the root of this equation. So let us divide this equation with x minus 2 and get the quotient, right? Let us get the quadratic quotient, which we can solve easily. So let us use our Horner's synthetic division. So you have 6 minus 11 minus 3, 2, and the root is 2 because the factor is x minus 2. So I'll write plus 2 instead of minus 2. So let us do the division. 6, 6 2s are 12, 1, 1 2s are 2, minus 1, minus 2. So the remainder is 0. Hence the quotient is 6x square plus x minus 1. You can very easily do the factorization for this. So minus 6 can be written as plus 3x minus 2x plus 3x minus 2x minus 1. This implies 3x times 2x plus 1 minus 1 times 2x plus 1. This implies 2x plus 1 times 3x minus 1 is equal to 0. So the roots are minus 1 by 2 and 1 by 3 and 2. So these are the three roots to this equation. Thank you.